I recently read some great articles about how GPS works, like this one from Bartosz Chehanovsky, and this one from Philip Tenon. I've left links to them in the description. After reading them, I found that I still wanted to know more, so I decided to build my own GPS receiver from scratch. And here it is in action. The antenna receives signals from GPS satellites, the dongle digitizes them, and the code on my laptop does the rest, processing the signals to eventually calculate my location. I even created a dashboard showing which satellites it's tracking, their status, and the most recent location estimate. In the process of building it though, I found that existing resources to learn about GPS were either too academic to be accessible or too high level to actually help you build your own receiver. I've made this video series to hopefully bridge that gap. My goal is that by the end of these 8 videos, you'll know enough about GPS theory that you can read and understand the code of my GPS receiver and maybe even build your own. I'm going to assume you're comfortable with calculus, complex numbers, and the properties of waves like amplitude, frequency, and phase. However, you don't need to know anything about GPS or signal processing. I certainly didn't when I started this project. Let's start with a high-level overview of how GPS works. A constellation of around 30 GPS satellites orbits Earth, but let's just consider one for now. Each satellite continually transmits radio signals, and those signals contain information that lets us calculate when they were transmitted and where the satellite was at that time. Let's say we receive a signal from this satellite, and we calculate that it was located here. We know when we received the signal, and we know when it was transmitted, so we can calculate how long it took to reach us, the transit time. We also know that the signal travels at the speed of light. Multiplying the transit time by the speed of light, we get the distance the signal travelled to reach us. If we draw a sphere around the satellite of that size, we know that we must be located somewhere on the surface of that sphere. Repeating this process for several satellites, the spheres will intersect. That point of intersection is an estimate of our location. Over the next 7 videos, we'll go into all of this in much more detail. The next 2 videos cover some background theory. First, we'll introduce the concept of correlation. This is a way to measure the similarity of 2 signals, and we're going to use it a lot. Next, we'll talk about the signals transmitted by GPS satellites, the types of signals they transmit, how to distinguish between them, and how to decode binary data from analog signals. Each video in the rest of the series covers a particular stage of the GPS receiver implementation. It starts with sampling, where we'll learn about the hardware we need to measure GPS signals, how to configure that hardware, and the form of data it'll provide. In the acquisition stage, we'll learn what parameters affect satellite signal strength, how to find the best values for those parameters, and how to use them to determine if a satellite is present. In the tracking stage, we'll learn how to track GPS signals as satellites move across the sky, and how to decode fragments of bits from those signals. In the decoding stage, we'll learn what information is contained within GPS signals, and how to decode it to be used to calculate our location. And finally, in the solving stage, we'll learn how to use that information we've decoded to calculate our location. I hope you'll find all of this as interesting as I do, and I'll see you in the next video.